Hey everybody, Mr. Fortin here. Going to go over one other problem from your weekend homework, number 27. Now, this problem also came up when I was helping somebody out who had already did the homework on Friday, and I was like, okay, this is also a pretty complicated problem for some people. So what I'm going to do is I'm going to film a video and send it out to hopefully get some help out there, but also save time come Monday's review, because sometimes we don't have enough time to spend as much time on a problem like this as some of you guys might want to get to the bottom of it. Okay, so anyways, so check it out here. You do have two C-level problems. Now, C-level problems can be very hard in the textbook here, but I think these ones are achievable. You'll see in a second here. This one's a little bit more achievable here. But you've already done number 26. Now, hopefully one thing that you got during Friday's class when we had that problem about the isosceles trapezoid with bases of 9 and 21 was the heights of those trapezoids. The altitudes to draw in, the kind of the smartest ones to draw in would be the ones that would originate from a vertex on the smaller of the base that we have here. Okay, so point Z, drop the altitude. Point Y, drop the altitude. Why is that a smart way? Because what is the shape in the middle here? It is a rectangle. Okay, it is a rectangle here. We know that the bases of a trapezoid are parallel to each other. So if I drop an altitude here, it's going to be perpendicular to one of two parallel lines. So it also has to be perpendicular to this line as well. Perpendicular up here. Okay, so hopefully you already did this problem and got it. Yeah, this side of 10 length here, I can get this distance because this is a 30, 60, 90 degree triangle. 5 root 3, I think, right there. Okay, and then here, you can figure it out. That's not why I'm filming this video. I'm filming this video for number 27. Okay, so for number 27, the principle of this is going to kind of be the same in that I'm going to use the idea of getting that rectangle in the middle set up. Okay, drop in these two altitudes. Remember, these two altitudes are going to be congruent because points on one of two parallel lines are equidistant to the other parallel line. So this point here and this point here, same distance away. And how do we measure distance? We measure it by the length of the perpendicular segment that you can draw from this point to that line. Okay, so these are congruent. Okay, so a few things here that you hopefully got figured out in this one as well. The middle shape is a rectangle. Okay, this is a rectangle. And then what are the other two shapes? Well, the other two shapes on the other side. So a trapezoid, if I drop two altitudes from the vertices on the smaller base to the larger base here, I'm going to get a rectangle in the middle, and then I'm going to get two right triangles. Okay, right triangle there and a right triangle there. So number 26 was a bit easier because you had special right triangles, so you could get, for instance, this side length very easily, and then hopefully that could help you figure out this guy here, but I'll save it for you to share on class come Monday. Here, you can drop in the rectangle, and you still get two right triangles. You get two right triangles here in this problem. These two right triangles, they're not congruent, right, because this hypotenuse here is 13. This hypotenuse here is 15, and they're not necessarily special, okay, meaning they're not 30, 60, 90 triangles. They're not 45, 45, 90 triangles. At least we don't know if they are because the problem did not give us any of the angle measurements here, okay? So the question is, how can I get it? What can I do? Well, whatever you start a problem like this, okay, you know that getting this middle rectangle is important. That's going to gather more intelligence about this problem. You're going to start picking away on it. Why? Well, because we would know that this length here, because this is a rectangle in the middle and opposite sides of the rectangle are congruent, this is me a side length of 10, okay? So here, I got this here is a length of 10. I know that. Let's get rid of the 24 right there. Let's move the 24 down there. I know the whole thing here is 24. Shoot. PQ is 24. We're sort of given that. Yeah, let's get that out of the way. Anyways, PQ is 24. So this is 10. So I know what's left over from that here. P2Z, and we'll make it Y here, I guess. PZ plus YQ has to equal what? Has to equal 14. Okay, has to equal 14. So this guy plus this guy equals 14. So maybe you're thinking at this point here, well, if they're going to split 14, we don't know how we're going to get there. What you should remember, we've done this a few times this year, the way we can get there is this. We can identify a variable for this. Just for one of these guys here, we can make it x. Okay, we can make it x. We can let the distance PZ equal x. And then that would tell us about this guy right here. We can actually write an expression for that guy, can't we? Why? Well, PZ plus YQ, what did it have to equal? It had to equal 14 because PQ as a whole was 24. And we know that, oh, ZY right here is 10. Why? Again, opposite sides of a rectangle, which is their parallelograms. They're congruent to one another, and congruent lengths have the congruent sides have the same lengths. Okay, so anyways, this plus this equals 14. Okay, so 14 minus X would have to equal that guy right there. Okay, I get it? 14 minus X. 14 minus X plus X would equal 14. Okay, so that's what we do here. And why is that good? Well, whenever we're introducing variables to a problem, you try to introduce as few as possible. Why? Well, you want to have as few unknowns as possible. You're trying to learn more about this problem. You're trying to solve the problem here. And if I just have an expression written using X down here, maybe I can figure out what X is. I don't have to worry about another variable. Okay, so here, I have X here. I have 14 minus X. Okay. How's this helping us? Wait, what? How's this helping us in? Well, whoa, let's think back to the original thing. This middle shape is a rectangle. What are the two things appended to the sides of that rectangle that make it a freaking trapezoid? Okay, well, right triangles. Okay, right triangles here. So I have an expression for this leg of the right triangle. I have an expression for this hypotenuse of the right triangle. What can I write for this? What can I write for this longer leg here? Well, that's the altitude. That is the height. That is the height here of the trapezoid, right there and right there, and they're the same, okay? They're the same here, and we're going to need that height to come up with the area. Yeah, we are. This is a big problem. That's why it's a sea level problem here, okay? Because area is going to equal 1/2 B1 plus B2 times by H. We're eventually going to use that formula for the area of a trapezoid. So we have 10 here. We have 24 here for the two bases. H we don't know. But what can we do with H right now, okay? We can actually set up an equation using H. How? Wait, can we only set up one equation using H? No, we have two right triangles that have H in them. Where am I going with this? That's right, a system of equations. This is definitely a problem where you have to, in order to solve this, you're doing a system of equations, not systems, system of equations. Now, Algebra 1, you should have done this almost all year in Algebra 1, okay? For me, I do this Chapter 3. Right now, I'm on Chapter 9 of Algebra 1. I practice all year after Chapter 3, okay? Systems of equations involve setting up not just one, but two equations, okay? The definition of a system of equation is two or more equations that share the same variables, okay? And you know what I can do is I can set up a system of equations. I can set up an equation using that right triangle. I can set up an equation using this right triangle, and they're going to have the same variables in there. They're going to have X. They're going to have H, okay? And what are those equations? Well, they're right triangles. So to set up an equation, what's the most famous equation that has to do with right triangles? That's right, the Pythagorean Theorem, okay? System of equations, and I'm going to use it using Pythagorean Theorem. Set up my system. So here, it's easier here for this triangle here because this is just X and H. I want to know that X squared plus H squared equals 13 squared by the Pythagorean Theorem, right? There's one. There's equation number one. So remember, system of equations is two or more equations that share the same variables. So my other equation I can use that triangle too, right? I can use this triangle to set up an equation using the Pythagorean Theorem. So that's just going to be 14 minus X squared plus H squared equals 15 squared. There it is. I have my system. This is my system of equations right here. Equation 1, equation 2. So now I do this all the time in Algebra 1, right? We're doing systems all year. We got to figure out how we can use both of these equations to identify what these variables have to equal, common solutions of both, because here we only have one H. Right? What does H got to be? What does X got to be to make it all work out? We got to massage these equations. We got to set it all up. And the way that I would do these equations, well, you could do it elimination. Elimination might be easiest here, but I'm not going to do elimination. I'm not going to do that. I want to do the equal values method, something called the equal values method, is the way I teach this in Algebra 1. So anyways, what I can do, right, there are a few ways we can solve systems here. One thing that I'm going to do, I'm calling this equal values method in Algebra 1, I'm going to call it the transitive property. Ooh, the transitive property in geometry. Here's what I'm going to do. I'm going to isolate H squared. Okay, H squared right here. Meaning, if I can rewrite this equation so that I get h squared equaling something. And I can rewrite this equation here so I get h squared equaling something. What can I do? Well, the transitive property tells us that two things, if you have two things that each equal the same thing, well, what do they equal? They equal each other. You can set up an expression here. So if I isolate h squared right here, this is what I'm going to do. I'm going to have h squared here, and I'm going to subtract x squared from both sides. That's how I can isolate h squared, okay? So over here, I only have one variable on this side of the equation. I have h squared there, so I still have two variables in this equation. I can't solve it yet. But I've isolated h squared. I have one variable here. I'm going to do the same thing over here. I'm going to get this h squared equaling 15 squared, and I'm going to subtract this quantity, 14 minus x squared, because check it out. I have now isolated h squared on both of these equations. So I know that 13 minus x squared, and I know that 15 squared minus 14 minus x squared, they equal the same freaking thing. They equal the same thing because we knew that because of the Pythagorean Theorem, and we isolated h squared. So what I can do, I can use the transitive property. Transitive property. When two things, this thing and this thing, each equal the same thing, then they equal each other. 13 squared minus x squared has to equal 15 squared minus 14 minus x squared. There we have it, okay? You could have done the elimination method. So I know you're thinking here, you systems masters here, you're like, I could have eliminated x, or not x squared, h squared really easily. Sure, good for you, but I'm doing it this way, okay? You can choose your best whatever you feel most comfortable with for your systems of equation strategies to solve, okay? Let's solve this freaking system. So we're going to get x first, and once I get x, it's easy. I can use Pythagorean Theorem to figure out h's. Let's do it. And then I got to get the area of the freaking trapezoid. Oh! So there's kind of a lot on this here. So to end your problem set, a little challenge problem at the end here, okay? Check it out here. A lot of people kind of have problems with this. So I'm going to ignore the negative for now. I'm going to do this 14 minus x squared. So remember that here, I use generic rectangles whenever I'm squaring something. 14 minus x means a square, right? Because I'm squaring it, that has a width of 14 minus x and a height of 14 minus x. So here I got 14 times 14. That's 196. I always forget 14 squared, but it is 196. 14 minus x is negative 14x. 14 minus x is negative 14x. Negative x times negative x is x squared. Okay, so I'm just multiplying this part here. I just know that that's binomial squaring it is something maybe you haven't practiced much recently at all here. Okay, so anyways, I get 15 squared. That's 225. So right now I'm just trying to solve for x, 225. And I'm going to subtract all this, what I did to multiply here. So I'm going to subtract 196. What else do I have to subtract? I have here negative 14x, another negative 14x. So I got to subtract, well, I'm subtracting, I'll remember my parentheses, baby. 196, and I'm subtracting, so I'm subtracting a negative here, a negative 28x. Okay, and that's a positive x squared right there that I'm subtracting. Okay, and that equals, well, here 13 squared, that's 169. You might be doing that to calculator, but it's nice to memorize these perfect squares here. 169 and then minus x squared. Okay, so we have this all. So okay, I'm gonna distribute the negative now, so as I kind of try to isolate what x has to be. Sorry, it's getting a little ugly. 225. Subtract 196. Okay, this negative is going to flip that negative to a positive, so plus 28x. And then here, negative is to flip that positive to a negative, negative x squared. That's nice because I have a negative x squared on this left side of my equation. I have a positive x squared, negative x squared on this side of the equation. So if I add x squared to both sides, shoot, that's going to knock out the x squared there. Nice. I don't need to use quadratic formula. I don't need to use factoring or completing the square to figure out what x is here. I just got to solve for x the good old-fashioned way by isolating it. Okay, so what I'm going to do now is, I have 225 minus 196. Maybe I clean that up a little bit. So I have 169. My x squared is canceled out. 225 minus 196 is going to be what? 25 plus 4 is 29. And this is plus 28x. I still have here 28x. Okay, subtract 29 from both sides. I get 140. Is this right? I don't know. I hope it's right. 140 equals 28x. Okay, and now I'm going to divide. I'm a little better about. No, I'm not feeling too good about this now that I did this right. I probably made a mistake somewhere. You have to catch me if you do a mistake that I made. I'm pretty sure I made a mistake. probably right here. Okay, divide both sides by 25. I get 5 equaling x. Oh yeah, I did this right. We're good to go. Okay, so check this one out here. So x is actually 5. What does that mean? Well, my missing dimensions here, PZ is 5. 14 minus x. Well, 14 minus 5 is 9. Okay, and it works out. 5 plus 10 is 15, plus 9 is 24. There we go. We got our whole base, the little components of the base after we drop the altitudes in. Can we get the height? We sure can. Why? 5, 12, 13. Sorry, 5, 12, 13. Pythagorean triple. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. That is 13 squared, so it works out. That's a Pythagorean triple. Okay, what about this one here? 9, 15. Well, that would be 9, 12, 15. So it works out in that one too. That's also Pythagorean triple. That's a 3, 4, 5 ratio. If I have a right triangle that has a 3, 4, 5 side lengths, I would know it's a right triangle, and then any scale factor beyond that. So I double it to 6, 8, 10. And I tripled it to 9, 12, 15. It's got to be similar to that original right triangle, so it's right triangle. Okay, so anyways, I have here my height, and I can finally do it. Yes! Now I can finally do it. The big thing was getting my height, which I did all that work. So I got 12 for my height. Base 1, the smaller base there is 10. Base 2, larger base, that's 24. Okay, so I just plug it all in, and I get my answer. Here, I'll just do it in our head here. 10 plus 24, well, I'm not going to do it in my head. Hey, I'm a teacher. I'm going to show it out. Okay, 10 plus 24, that's 34. Okay, and then we have 12 here. So 1/2 times 34 is 17. So remember, the 1/2 just goes to whatever the first parentheses in front of it is. Okay, so this makes this 17. Okay, and then I have 17 times by 12. That's going to get us to our answer here. Okay, so 17 times by 12 is, booyah, 204 square units. Okay, and you don't have to write square units because they don't really care about that if they didn't specify the units in the original problem. There's your answer. Okay, who's going to present that on Monday? That's right. Somebody present that on Monday. Thank you for watching, guys. Hope you have a good weekend. Send me any messages if you want to hear any explanations to other problems. Thanks. Bye. I'm going to stop this video.